I don't want to tell you about where you can see corrosion around you. At least once in your life, you might have encountered corroded rails, vehicles, etc. In this video, we will talk about corrosion. One misconception about corrosion is that it occurs only on iron since we see rusting of iron. However, rusting of iron, tarnishing of silver, tungsten, development of green coating on copper and bronze are some of the examples of corrosion. It causes enormous damage to the buildings, bridges, ships, and to all objects made of metals, especially that of iron. We lose crores of rupees every year on account of corrosion. Corrosion is the general term used to describe metal atoms getting covered by oxides or other salts of the metal. In corrosion, a metal is oxidized by loss of electrons to oxygen and results in the formation of oxides. This shows that corrosion is essentially an electrochemical process. We discuss the corrosion of iron, which is generally known as rusting. Iron corrodes in the presence of water and air. Let us try to see the chemistry behind the corrosion of iron. Consider an object made of iron, and in this object, at a particular spot, oxidation of iron takes place, and so this behaves as anode. And we can write the reaction as 2Fe gives 2Fe2++, 4 electrons, with a cell potential of minus 0.44 volt. Electrons released at anodic spot move through the metal and go to another spot on the metal and reduce oxygen in the presence of H+. This spot behaves as cathode with the reaction O2 plus 4H plus 4 electron gives 2H2O. The cathode potential is 1.67 volt. These H+ ions become available from the carbonic acid H2CO3, which is formed due to the dissolution of carbon dioxide, or from the hydrogen ion in water, which made available due to the dissolution of other acidic oxides from the atmosphere. Now, the overall reaction of these electrochemical reactions would be 2Fe plus O2 plus 4H plus gives 2Fe2 plus 2H2O with a cell potential of 1.67 volt. The ferrous ions are further oxidized by atmospheric oxygen to ferric ions, which come out as rust in the form of hydrated ferric oxide with the formula Fe2O3.xH2O, and with further production of hydrogen ions. Finally, let us discuss the ways to prevent corrosion. Many buildings and bridges around the world collapse due to the corrosion of iron rods and all. To save money, it is important to prevent corrosion. One of the simplest methods of preventing corrosion is to prevent contact between the surface of the metal object and atmosphere. This can be done in many ways. Simply, one can cover the surface with paint or by some chemicals like bisphenol. However, due to the side effects like heart diseases, bisphenol is not used for covering the surface. Next is by plating the surface of the metal with other inert metals like tin, zinc, etc. Another method is cathodic protection by making the metal surface the cathode of an electrochemical cell. Here, a sacrificial electrode of another metal like magnesium or zinc is corroded and the object will be protected. Cathodic protection systems are most used to protect steel pipelines and tanks and offshore oil platforms. We have already discussed about using hydrogen-oxygen fuel cell and the efficiency of the cell. With that idea in mind, try to find more about hydrogen economy and how it would impact the future of energy economy. With this, let us summarize this video.
Manorama Horizon. Learning made simple.